Hey Ramblers, this video covers chapter 3.3 in our textbook and deals with two very important rules for differentiation. We're going to learn the product rule and the quotient rule. Up till now, we've really only learned how to deal with some pretty basic functions. We got the constant function, the power function, and exponential function. We can deal with sums and differences of functions, but nothing more complicated than that. And certainly nothing as complicated as a composite function. So tonight we're going to look at the rule for when we have to differentiate two functions that are multiplied by each other or two functions that are one dividing the other. So I'm going to give you the rule, and then I'll give you a couple of examples to work on through Zaption. So please take your time. Try to learn these as we go along because it's going to be an important week. Things will be hard to follow in class if you don't have these rules down. So take good notes, pause often, and thanks for watching. Okay, up till now, we've really only learned a handful of rules. We can handle differentiating y equals something like x cubed, because we know that y prime is just going to equal 3x squared after we apply the product rule. And we know we have a sum and difference rule, so if y equaled x cubed plus 2x squared, we could easily differentiate that as y prime equals 3x squared plus 4x. And if we had something like y equals 2 to the x plus 7, we could just get the derivative of that as 2 to the x ln of 2 plus 0. So these are pretty basic functions, and they're examples of everything we know. But what happens if we get two functions that are multiplied together? So y equals something like 3x squared times 2 to the x. It's not as simple as just taking the derivative of each one. And so we have to apply something called the product rule. Now, I'll be honest with you. Math classes always got me a little confused because they would go into very long proofs, and I would lose the concept in the long proof. So let me give you what the product rule states, and then kind of box it and make sure you understand what it is without confusing things with the long proof. Okay, the product rule is this. If we have the product of two functions, f of x and g of x, and we're taking the derivative of that product, it simply equals the derivative of the first function times the second plus the first function times the derivative of the second. Now, in this textbook and in others, you'll see the two functions notated as u and v. And so the derivative of the first is du dx. The second function is just v. The first function is u again, and the derivative of the second is dv dx. That's what's going on in this second definition. But in words, it's just the derivative of a product is the derivative of the first times the second plus the first times the derivative of the second. It's really not as bad as it looks. So let's take a couple of examples. I'll have you put them in Zaption, and you'll see that it's not so bad. Suppose we're given that y equals 3x squared times 2x. So what we're going to do is apply the product rule. Now, just so we're on the same page, the product rule is the derivative of the first times the second plus the first times the derivative of the second. So in this case, the first function is 3x squared. So the derivative will equal 6x, because that's the derivative of 3x squared, times the second, which is just 2 to the x, plus the first, which was 3x squared, times the derivative of the second, which, as you recall, is 2x times the natural log of 2. Okay, so it's a little more complicated than it would have been had we just given you, the derivative of each one, but it's correct. Now, why don't we try a couple, why don't you try some, and we'll turn them into Zaption. let's say y equals t squared plus 3, and that whole quantity is times e to the t. All right, give that a shot. Okay, well, we're going to use the product rule here because we have two functions. T squared plus 3 is one, and e to the t is the second, and we're multiplying them together. So the derivative of t squared plus 3 is 2t times the second function, which is just e to the t, plus the first, which was t squared plus 3, times the derivative of the second, which is complicated because it's e to the t is its own derivative. So we get e to the t again. But that's how you do the second problem. All right, let's try another one and turn it into Zaption. How about x squared times e to the x? Take a minute and do it on your own. Okay, well, y prime is going to be the derivative of the first, which would be 2x, times the second, plus the first times the derivative of the second, which is once again just e to the x. I hope you're catching on. Let's try one more. Okay, suppose we had y equals e to the x over x squared. Now, how would we handle that? Now try thinking about this one, and maybe you have to simplify it or change it from what appears to be a quotient into two things being multiplied together. So give that a second and try it on Zaption. Okay, well, the derivative here, or I'm sorry, the original function can be rewritten here to be e to the x times x to the negative 2. Okay, now I can apply the product rule. So y prime is going to equal the derivative of the first, which is, of course, just e to the x again, times the second, which is x to the negative 2, plus the first, e to the x, times the derivative of the second, which will be negative 2x to the negative 3. So that would become our answer to this quotient if we turned around and made it a product. Okay, we use the quotient rule anytime we're trying to take the derivative of a quotient of functions. That is, something in the form of f of x divided by g of x. Now that last example, we could have used the quotient rule on it as well. But there is another rule that we need for functions where we can't simplify the quotient to be represented as a product. And so the rule is this. It's a little more threatening than the product rule. But let's let u equal f of x and v equal g of x. And so f divided by g prime would equal the derivative of the first times the second minus the first times the derivative of the second, but this time we divide by g squared. So in other words, maybe written out, it's a little less formidable. So the derivative of a quotient, f of x divided by g of x, is equal to the derivative of the numerator times the denominator, or the divisor, minus the numerator times the derivative of the denominator, all divided by the denominator squared. Now, there's a little mnemonic that I think is really helpful. If we were to refer to the numerator, or what's being divided, as high, and the denominator as low, then we get a little rhyme. It's low, d high, and when we say d, we mean kind of derivative of the high, minus high, d low, all over the square of what's below. So that's kind of low squared. And that's another way of representing the quotient rule. Low d high minus high d low over the square of what's below. I probably say it every time I do the quotient rule. Okay, let's take a look at a couple of examples and then we'll wrap up. Okay, what would be the derivative of 5x squared over x cubed plus 1? Let's pause the video for a minute and put your answer on Zaption, and then come back and we'll see how to work it out. Okay, well, using the quotient rule, because there's no way to break up that denominator, I will have to say low d high, which would be 10x, minus high d low, which would be 3x squared, all over the square of what's below. Now, in calc, we tend to not simplify things, but maybe just simplifying a bit in the numerator would be okay. Let's see what that looks like. Okay, so the numerator simplifies to the binomial negative 5x to the fourth plus 10x, and then we're not going to bother to expand the denominator, just leave it the way it is. Okay, Ramblers, long video, but those two formulas, the product rule and the quotient rule, are the ones you need to remember. So make sure those are in your notes. If not, rewind and go get them. And thanks for watching. Okay, Ramblers, so we have, in this video, covered two really important rules for finding derivatives. The first was the product rule, and we use that whenever we're finding the derivative of two functions being multiplied together. Make sure that you get this in your notes. It's the rule that, you know, has the plus sign in it, or it doesn't have a denominator. The second one was the quotient rule, and let's make sure that's in your notes as well. And that was when we're finding the derivative of a quotient, or one function being divided by another. Quotient rule is easy to recognize, has that negative sign. It's also being divided by the square of the denominator. Ramblers, I hope this helped. Please make sure these two rules are in your notes, and thanks for watching.